So I want to get you started on just this Venn diagram here. I want to remind you again that a Venn diagram has like circles, and circles are inside of circles because they include certain things. So if you take all linear equations, if you look at this guy right here, this whole box is saying all linear equations are going to go in this box, but then this circle right here is a direct variation. And so this direct variation is inside the linear equation box because remember, a direct variation is a straight line. It just goes through the origin, right? So anything out here are going to be just your linear equations that aren't considered direct variations, and here are going to be your direct variations, and it's inside the linear equations because a direct variation is a linear equation. And then over here on the left, we have this separate little box that's not part of linear equations because this is inverse variation. And inverse variation are equations that are curves, so they're not lines, they're not straight lines, they're linear. So let's just review the forms really quickly. If you know them, go ahead and write them in and then double check to see if you're right. But inverse variation, remember, is in the form y is equal to your constant over x. So that would be an inverse variation where k is your constant. And x and y are just points on the line or the curve. And because there's infinitely many, that's why we keep the x and the y in part of the equation. Like, that's the rule for the inverse variation. And the k is the thing that's constant throughout the entire graph. Direct variation is in the form y equals kx, right? And k, again, is our constant or our slope. Linear equations are everything else that are in the form like y equals mx plus b, right? And y equals kx is still a linear equation. So what I want you to do down at the bottom, be sure to read the directions. What the directions tell you, solve each equation for y if it isn't already, then write each equation in the appropriate section in the graphic organizer. So we're going to decide, does it go in here, does it go just here, or does it go here? So let's go ahead and take the first one. Let's solve for y. So when I solve for y, you need to subtract x from both sides and then divide by 2. So when we subtract x, we get 2y equals 14 minus x, and then we divide everything by 2, and I'm going to put that up here because we're running out of room. I'm going to get y is equal to, you're dividing everything by 2, so it's 14 over 2 is 7, and then remember the coefficient of x is 1, so that's minus 1/2 x. So if you look at that, is that inverse? Is it just a linear equation or is it direct variation? And that's just a linear equation. It has a y-intercept of 7 and a slope of negative 1/2. So you're going to write in here y equals negative 1/2 x plus 7. And that's where that one goes. So the next one, y equals x. Well, y is alone. This, remember, is our parent function. Don't forget about the parent function. That is a linear equation, but it's also a direct variation. So y equals x, it goes right through the origin. It has a slope of 1. So y equals x goes in the direct variation circle. X times y equals 30. Well, we have to get y alone to be able to decide. So we're going to divide both sides by x. And you get y is equal to 30 over x. Well, that one's inverse. So we're going to put y equals 30 over x inside the box. So put the y equals form inside the equation. That way I know you've actually solved them for y. All right, so the next one, get y alone. I have to multiply both sides by negative 7. And so the 7's cancel out. I get negative 7x equals y. Well, that's in the form y equals kx, right? Y-intercept 0, the slope is negative 7. That's a linear equation, but it's also a direct variation. So we're going to put y is equal to negative 7x in the box. So you're going to basically do that for the rest of the problems on your page and make sure you remember to put them in the correct place in the Venn diagram. Good luck.